Okay, we're going to be graphing parabolas with tables. And just a little bit of background information. If you have a quadratic equation, that means equation that's the second degree. It's in this form of y equals ax squared plus bx plus c, and as long as a is not 0, because a's got to be some number, otherwise we wouldn't have a quadratic, so a cannot equal 0. Put that little stipulation in there. Okay, if you have an equation in this form, as long as a is not equal to 0, it's a quadratic equation, and it will graph to be a parabola. Now, if the a is positive, that means I've got a positive x squared or something like x squared. It would be shaped like a u, 3x squared, 4x squared. Be a little skinnier, a half x squared be a little bit flatter. Okay? If a is less than 0 or negative x squared or something like this, it's shaped like an n. Now, you can kind of remember that because an n is the first letter of the word negative. So if it's negative, it's shaped like an n. If not, it's shaped like a u, so it's easy to remember. Now, we also have functional notation, and a function is a rule. And remember, when we graph these things, we have a x, which is sometimes called the independent variable, and a y, which is called the dependent variable. The x is on the horizontal axis, and the y is on the vertical axis, and it tells us as we put data in what our values are going to be, vertical positions. So sometimes we're given this notation y, sometimes we're given f of x. They both mean the same thing. X is the first coordinate, the horizontal, y is the vertical component if we graph these, or x, f of x. So if we see this function, it's a rule. This just says 2 times something squared plus 3 times something plus 1, whatever this something is. In this case, it's x. So if I want to put a number in like 2, or 3, let's try 3, f of 3, then that means evaluate this rule, this function at 3. So every time I see an x, I'll put a 3. And then we can find the value of that. That would equal 3 squared is 9, 2 times 9 is 18, 3 times 3 is 9, plus 1, and that's going to be 28. So the point on this curve, if we graph this, that would be the point 3, that's the x, and f of 3 is the y value, and in this case, it's 3, and f of 3 is 28. So that's how you take care of that notation. Now let's take a look at the example in the worksheet and what the worksheet's saying, and it's written pretty well. It just says that if we want to find the vertex of a parabola, if we have a parabola in this form, we can identify the a, the b, and the c. Then we know that the x-coordinate will be negative b over 2a, and whatever that is, we can substitute that into the function and we'll find the y-coordinate. So let me show you what I just said so you know. If I look at this, what's in front of the x? 1, so I know that a equals 1. What's in front of the x squared? A equals 1. And what's in front of the x? 2, so I know that b equals 2. Now I know that the vertex, the x value of the vertex, x equals negative b all over 2a, forget the negative, okay, negative b over 2a, and that's going to be, I hope you can see that, you can always zoom in, and that's going to be negative, and b is 2, so that's going to be negative 2 all over 2 times a, and a is 1. So that's going to be negative 2 over 2, which is just negative 1, so that's going to be my x value. So I guess I can write it up here. Or my vertex, this is the vertex. And the x value will be negative 1. Now how do I find the y value? Well, I take f of negative 1. So the y value will be f of negative 1. So I'll just put that in the rule. So the rule is y equals x squared plus 2x minus 2. See? Y equals x squared or something squared plus 2 times that something minus 2. So what I'll do is I'll put so this is y, and this is, like I said, you could write it like this. Y equals x squared plus 2x minus 2, and then it's just open like this. And then we could say f of x, or f of something, and I want to find f of negative 1. So I put negative 1 here, and every time I see an x, I'll put a negative 1. All right? And then this is going to be negative 1 squared is 1 minus 2. 2 times negative 1 is negative 2 and negative 2. And 1 and negative 4 makes negative 3. So that's going to be the y-coordinate. So my vertex will actually be at negative 1, f of negative 1, which was negative 3. So that's where my vertex will be. So that's how you find the vertex. Okay? Hope that makes sense. And that's what they did in this table. Now they want to find the other values. They want you to find two values less and two values greater than the vertex. So we want to find f of negative 2 and f of negative 3. All right? So I'll just do that over here. So a little bit of room here. Remember f of x equals, and my rule was, if you look over here on your worksheet, x squared plus 2x minus 2, or something squared plus 2 times that something minus 2. So if we take f of negative 2, one less than that, what are we going to get? So I'll put negative 2 in here. And that's going to be negative 2 squared is 4, positive 4. And this will be negative 4. Oops. And that's going to be negative 2, so I'm just going to end up with negative 2. So that means the point negative 2 will be on the graph, so I'll just put my negative 2 in there. Now let me take f of negative 3. So every time I see an x, I'll put a negative 3, f of negative 3. And what's negative 3 squared? That's going to be positive 9 minus 3 minus 2. Oops, sorry, I forgot the 2 here, excuse me. X squared plus 2x minus 3, so that's going to be negative 6, pardon me. And 9 minus 8 is going to be just 1, so I'm going to have a 1 there. Okay, and let's try the 0. Well, this isn't too bad, because if we look at our function, f of 0, that's just going to be 0, 0 minus 2. I'll show you so you can see it, f of... Well, if I put a 0 here, I'm just going to have all zeros. Here, f of 0 will be 0, 0, so that's just going to be negative 2. And there is a symmetry about these parabolas. Let's do one more. Let's do f of plus 2 times something minus 2, and I'm going to put a 1 in. And what's f of 1? Well, it's going to be 1 squared is 1, plus 2, minus 2, and that's going to be 2 minus 2 is 0, so that's just going to be 1. So those are your values. Now we can graph this. And if you don't have graph paper, you can kind of make your own graph paper. But some of these you have to use different scales. So I'll graph it over here. This is the y, and this is the x-axis. Sorry about that. And then I'll try to make my scale relatively consistent. So this would be 1, 2, 3, 1, 2, 3, and get that distance -1, -2, -3. So I'll put my points in that I got from my table, from all these different values I got for these tables. And remember, my vertex is at -1, -3. So this is -1, and this is -3, and there's my vertex. And remember, it's positive, so it's shaped like a U, so I know it's going to go up like this. So this is -2, -2, so I go over to -2, and that's -2, -2. And I go to -3, and I get 1. I'm going to put a 1 over here. This is -3, 2, -3, 1, 2, 3, and this is 1. So -3, 1, so I have a point over here. And there's half my parabola. And on the other side, when x is 0, it's -2, so that goes there. And then when x is 1, it's going to be +1. And it goes there. So there's your parabola, and you connect those points. And always kind of make this look like a little bowl down here. And you just kind of sketch those through there. And there's your parabola using these points. So that's this example. And I'm going to do number 6 in the next video so you can see that. Okay, that makes sense.